Hi all, this is Keerthana working as an assistant professor in S.A.E. Engineering College in the Department of Artificial Intelligence and Data Science. Today I am here to talk about basic sorting techniques in data structures. What is sorting? Sorting is a rearrangement of element in a particular order, either in ascending or descending order according to the comparison operator. What is a comparison operator here? Comparison operator is nothing but it is used to decide new order of an element with respect to the data structures. Here we see unsorted data structures and we have to apply any one of the sorting techniques to become the unsorted array into a sorted array. Okay. Then why sorting is needed? Why sorting is needed means it reduces the complexity of the problem. Complexity is nothing but difficulty of solving the problem. Okay, then let us assume if we have a small amount of data set in an unsorted manner. If you want to search an element in an unsorted element means it is very easy for us because it is a small data set. Rather, if we want to search in an element in an unsorted element in a huge data set, it is very difficult for us to search an element in an unsorted array or unsorted list. For this we need a sorting techniques. Sorting is nothing but already I said sorting is an arrangement of element in a particular order. If we arrange the element in a particular order means if we want to search an element if in large data set also, it is very easy for us to pick that element or pick that position in the sorted array. Okay. Next, already I said comparison operator. Based on the comparison operator, sorting algorithm is of two types. One is a comparison based, another one is a non-comparison based. In comparison based, it is of 6 types. One is selection sort, bubble sort, insertion sort, quick sort, merge sort and heap sort. In non-comparison based, it is of 2 types. One is counting sort and another one is a radix sort. Next, we see about what is selection sort. Selection sort is nothing but it is used to find the smallest element in the unsorted list and place that in a sorted list. Okay. Initially, the array is divided into 2 parts here. One is a sorted part and another one is an unsorted part. Initially, in selection sort algorithm, the sorted part is an empty and unsorted part is a given array. Okay. Then we have to given array. Sorted part is always left side of the array and unsorted part is always placed right side of the array. Okay. In selection sort, we first select the smallest element in the list and place that first smallest element in the first position, and then we have to find out the second smallest element in the list and place the second smallest element in the second position. This process is continuous until the entire array becomes sorted. So this is the technique used in selection sort algorithm. Okay. The algorithm steps involved in selection sort algorithm is, first step we have to first select first element as a selected element, and then we have to compare the selected element with all the other elements in the array. First we have to select an element in the array, then we have to compare the selected element with all the other elements in the list or array. Okay. In this comparison, if we found any element smaller than the selected element, then we do swapping. Okay. This process is continuous until the entire array becomes sorted. These are the steps involved in selection sort algorithm. Okay. Next, the logic behind in selection sort algorithm are here we take it as an example with a size of 6 here because we have 6 data. Size is 6. We have size is 6 here. We have from the index of 0 to n minus 1. So here index starts from 0, 1, 2, 3, 4 and 5. Here the array of the index starts from 0 to n minus 1. Here the size of an array is 6. Then already I said before, the left side of the part is an sorted part and right side of the array is an unsorted part. Initially I said the left side of the part is an selected sorted part which is an empty, then unsorted part is an given array. Okay, now we do for an selection sort operation. Now already I said in the algorithm, first we have to select the first element in the position and we have to compare the first element with all the other elements in the array. So first index, so we have to point the first element as I here. Okay, then we have to compare I with all the other elements in an array. So j points to next to I. Okay, then for comparison algorithm we have two loops. For one is for I loop and another one is for j loop. So here we can take I is equal to 0, I is less than size minus 1. Here the size is 6, so 6 minus 1, 5. So 0 is less than 5. Yes, the condition becomes true. Then it goes to the j loop. Then j is equal to I plus 1. Here I is equal to 0. So 0 plus 1. So j is equal to 1. 1 is less than 6 because size is here 6. So the condition is true. Yes, 1 is less than 6. Then we have to check the if condition. If array of I, here array of I is 0th index, pointing to 0th index. So array of I here is 23. So 23 is greater than array of j. Array of j pointing to first index value which is 78. 23 is greater than 78? No, the condition becomes false. Then we have to increment the j value here. Okay, then increment the j value to here to 0 plus 2. We did not increment the I value because we selected the I. We have to compare the I with all the other elements in an array. So we have to increment the j value only. Okay, so we have to increment the j to here. Okay, then j pointing to the index of 2. So 2 is less than 6. Yes, the condition becomes true. Then we have to check array of I pointing to the 23 only. So 23 is greater than, now j pointing to 45. So 45, yes, it is, this condition becomes false because 23 is not greater than 45. So again j incremented to 3. Now this becomes 3. 3 is less than 6. Yes, the condition becomes true. Then it goes to the condition to check the if condition. Array of 0 here points to 23. So 23 is greater than, again j is incremented to 3. So here next 23 is greater than 8. Yes, the condition becomes true. Then if the condition becomes true means it goes to body of the loop. Okay, here we are performing a swapping operation, swapping of array of 0 and array of j. Here array of 0 and array of j is 3. So we have to swap this value and this value. So the array becomes 8, 78, 45, 23 and 32 and 56. Now this becomes, this is an array now. Okay, then we have to increment the j value because we have to compare the I value with all the other elements in the array. So now I becomes here. Okay, 0, 1, 2, 3, 4, 5. Now I plus j pointing here. Okay, now j can be incremented. So j is incremented to 4th position, index of 4. Okay, so now array of I is Now 8. 8 is greater than, now array of j pointing to 32. No, the condition becomes false. Then the loop can be continuous and j incremented to next position of I. Okay, so 5 is less than 6. Yes, the condition becomes true. Then it goes to here and it checks the condition. Array of high now 8. 8 is greater than 56. No, the condition becomes false. Then it goes to here. Then j incremented. J is incremented to 6. Okay, 6 is less than 6. The condition becomes false. So it come out of the loop. Okay, it come out of the loop. Then I incremented. Then it goes for an I incremented loop. Okay, now I can be incremented to 1. Okay, next 1 is one is less than 5. Yes, the condition becomes true. This is the sorted array. 8 is an sorted one and the remaining things are unsorted array. Okay, for first iteration we get an output as an 8 is in unsorted array and remaining is in unsorted array. Okay, now we have to increment the I value. Now I becomes 1. 1 is less than 5. Yes, the condition becomes true. Then it goes to j loop. Okay, now I is I pointing to the first index, so I is here. Next j is equal to I plus 1. Okay, I is already 1, 1 plus 1, so j is here now. Okay, next j is an 2, so 2 is less than 6. Yes, the condition is true. Then it goes to the check the if condition. Now array of I. Now array of I is array of 1 value. Array of 1 is 78. 78 is greater than 45. Yes, 78 is greater than 45. Then we have to swap the array of I and array of j. Now it becomes 78 here and 45 here. Okay, now high value 78 is greater than 45. Yes, we have to swap 45 here and 78 here. Okay, then we have to increment the j value. J value is incremented. J value is incremented to 3. So here now we have to check I value is now 45. 45 is greater than 23. No, 45 is greater than 23. Yes, the condition becomes true. Then we have to swap the 45 and 23. Now 23 becomes here and 45 becomes here. Now j is incremented to 4. Okay, because we have to increment the j value. Here already I is an 1, 1 plus 3. Previous incremented is 3. So 1 plus 3, j is incremented to 4. 4 is less than 6. Yes, the condition is true. Then we have to check the if condition. Now array of I. Now I value is 23. 23 is greater than 32. No, the condition becomes false. Then we have to increment the j value. Then we have to increment it to 5. 5 is less than 6. Yes, the condition becomes true. Then 23 is, now we have to check 23 is greater than 56. No, the condition becomes false. So next we have to increment the j value. J becomes 6. 6 is less than 6. No, the condition becomes false. Then we have to come out of the loop. Then we have to again increment the I value. Now the sorted array is this one. 8 and 23 is a sorted array and 45, 78, 32 and 56 is an unsorted array. Likewise, we have to compare, we have to take one element and we have to compare that element with all the other elements in an array and we have to perform the swapping operation. Okay. Next we have to take we have to take as an 23, 45, 78, 32 and 56. Okay, first here Next, I can be incremented as 2. Okay, now I pointing to here, we have to perform same operations for I and j. We can take it as an I element here, and I is compared with j, 45 is compared with 78. If 45 is greater than 78, no, the condition becomes false. Then we have to increment the j value, then 45 is greater than 32. Yes, 45 is greater than 32. If condition is true, means it goes to the body of the loop. Here we perform the swap operation, so 32 goes here and 45 goes here. Okay, we do the swapping operation, then j incremented, j becomes here, then 32 becomes here, and 45 becomes here, and 78 and 56. Okay, now j value is 56, I value is 32. 32 is greater than 56. No, the condition becomes false. Okay, then we come out of the loop. Okay, now the sorted array is 8, 23 and 32. The unsorted array is 78, 45 and 56. Now I pointed to 78. Okay, j pointed to 45. Okay, now I is compared to 45. Okay, 78 is greater than 45. Yes, the condition becomes true, so we have to do swapping operation here. 45 becomes here, and 75 here, and 56 here. Next, we have to increment the j value. J value is incremented here, and then we have to compare 45 with 56. 45 is greater than 56. No, the condition becomes false. Then it come out of the loop. Okay, then now the sorted array becomes 8, 23, 32 and 45. Unsorted array is 78 and 56. Now I is here and j is here. I is compared with j. 78, same condition. 78 is greater than 56. Yes, the condition becomes true. If the condition is true, we have to perform the swapping operation. So we have to swap the 56 here and 78 here. Okay, the final sorted array is 8, 23, 32, 45, 56, 78. Okay, this is the logic behind in selection sort algorithm. Already I detailedly explained about the logic behind here. Just I convert this into an lines. First we have to select the first position element in the list. Okay, then we have to compare it with all the other elements in the list, and whenever we found a smaller element than the list at first position, then swap those two elements. Okay, first element compared with all the other elements in the list. Once we found the smallest element than the selected element, then we do an swapping operation. This is the logic behind in selection sort algorithm. Okay, now 8 becomes the sorted array, and this things comes under unsorted array. Okay, in second line, select the second position element in the list and compare with all the other elements in the list. Okay, same, take this as this element in the list, selected element, and compare this element with all the other elements in the list. Whenever we found smaller element than the selected element, we have to perform the swapping operation. Here 23 is smaller than the 78, so we do a swapping operation. So 8 and 23 becomes sorted, and remaining things comes under unsorted array. Now we can take the third position element 45, and 45 is compared with all the other elements in the list. Then we found a small element than the 45, then we do swapping. Likewise, we repeat the process until the array becomes sorted. Okay. Next, for this we have to calculate the time complexity and space complexity of the selection sort algorithm. already I detailedly explain about the logic behind the selection sort. So here how we have to calculate the time complexity means time complexity is nothing but total amount of time taken by the algorithm to produce an result, to produce an output, to produce a sorted array. So that time taken will be calculated as a time complexity here. Here we have to perform we have to calculate by using two for loops. Here we using two for loop, one for I and one for j. For is an selected element and j is for an comparison element. Okay, for I is equal to 0, j will be iterates, the inner loop will be iterates up to 5 times. If I is equal to 1 means the inner loop will be iterates 4 times. If I is equal to 3 means the inner loop will be iterates 3 times. The I is equal to 3 means the inner loop will be iterate 2 times. I is equal to 4 means the inner loop iterates 1 times. Okay, already in previous example I will take as an size of 6 elements. I already discussed example of 6 elements in an array. For that I am explaining this time complexity. Okay, already here the size is 6. Okay, time complexity can be calculated as 1 plus 2 plus 3 plus up to n minus 1 values. Okay, so here 6 is an n minus 1 up to 5 iterations we have to calculate the time complexity here. If we take it as an size is n, then time complexity calculated as 1 plus 2 plus 3 plus up to n minus 1. Already we know sum of natural numbers calculate equation. Sum of natural numbers from 1 to n is an n into n plus 1 divided by 2. This equation is nothing but sum of natural numbers equation from 1 to n. Okay, then we have to, here n is n minus 1. Okay, so we have to substitute n is equal to n minus 1 into n minus 1 plus 1 divided by 2. Here minus 1 plus 1 cancel, so n minus 1 into n divided by 2. Okay, which is nothing but n square minus n divided by 2. We have to we always take highest degree as an time complexity, so n square, it is an order of n square. Okay, this is the time complexity of selection sort algorithm. Okay, next how we calculate a space complexity. Space complexity is nothing but total amount of space a particular algorithm will take to produce an output. How much space it will take for executing the algorithm to produce an output. Okay, here we take it as a list or array. So array of n units. Okay, array of n units. Then size, here we mentioned the size of variable takes as 1 unit. Then I for loop I and j, here I takes 1 unit and j takes 1 unit. So space complexity here is n plus 3. Here the constant value will be neglected, so it can be given as an order of n. Okay, next auxiliary space complexity. Auxiliary space complexity is nothing but extra space used by an algorithm. Here in this algorithm I and j only use one extra spaces. So overall auxiliary space complexity is 2. Okay, here it is a constant value, so it becomes order of 1. Okay, yeah, for this reason it is called as an in place sorting algorithm. Selection sorting algorithm is also called as an in place sorting algorithm. Okay, next we seen about how to calculate the time complexity. Here we see in time complexity we have 3 cases. One is best case, second one worst case, third one is an average case. In best case, best case always occurs if the input is in already in sorted manner. Okay, if the input array is in already sorted manner, it comes under the best case. Okay, for this here the number of comparison occurred or C of n is equal to n into n minus 1 divided by 2. Already we see in the time complexity. This is an equation of n natural numbers. So which is in the order of n square. Okay. How many number of swaps occurred in the best case means because it is 0 because it is already sorted. So we did not want any swapping operations. We did not perform any swapping operations because it is in already sorted manner. So which follows an order of 1. Okay. Next, time complexity for worst case. Worst case occurs if the input list is sorted but in reverse order, other descending to ascending order. Okay, that is called as an worst case. Here the number of comparison is same as best case, n into n minus 1 divided by 2, which is in the order of n square. Same like so number of swap. Number of swap is n, so which is in the order of n because it is then reverse order. If we perform the operation ascending to descending, we are n means number of integers in an array. If n is 5 means 5 times the swapping operation will occur because it makes the order into a sorted order. Okay. Next, average case. Cases occurs if the input list is in random order. Here the number of comparison also calculated as order of n square and the number of swap here is order of n. Okay, that's all about the selection sort algorithm. Now we can solve the gate questions. Okay, related to selection sort algorithm. First question, which one of the following in place? I already said selection sort algorithm is also called as an in place sorting algorithm. Okay, in place sorting algorithm needs the minimum number of swap. Already I said before, the swap in selection sort, the number of swap order it follows in the order of n. So in this the answer is selection sort because selection sort only follows minimum number of swapping operations. Okay, to sort the unsorted array into a sorted array. Okay. Next question. The worst case running times of insertion sort, merge sort and quick sort and selection sort respectively. Already I said about worst case order of n square. Okay, in insertion sort it is an order of n square only, quick sort order of n log n and selection sort order of n square. So D is an answer. Next, what is the number of swap required to sort n elements using selection sort in the worst case? I already said before, n is a number of integers in an array. So it follows an order of n. Okay, in worst case it follows an order of n. Next question, consider a situation where swapping operation is very costly. Which of the given sorting algorithms should be preferred so that the number of swap operations is minimum in general? Already I said before, the number of swap is compared with all the algorithms, number of swap is less than selection sort. So in the situation of very costly also, selection sort algorithm is used for swapping operations. Okay, because it follows an order of n. Okay, these are the questions already asked in previous year question papers. Okay, that's all about the selection sort. Thank you. Let's continue in the next section.